Hello and welcome to this IChemE Global Awards webinar. My name is Matt Stalker and I'm going to be your host this morning. The IChemE Global Awards celebrate chemical, process and biochemical engineering excellence and are widely recognised as the world's most prestigious chemical engineering awards. Today we'll be announcing the winners of the IChemE 2020 Best Consultancy Award and the IChemE 2020 Business Startup Award, both sponsored by the Chemical Engineer. So let's get started with the Business Startup Award. This award recognises the organisation formed in the last 5 years to best demonstrate its contribution to the chemical and process industries. Here are our finalists. We have Biosimulytics, Lixia, a joint entry from Posidon Plastics, Green Lizard Technologies and the Netherlands Process Design Centre, and finally the University of Hong Kong. All of our finalists have been invited to join us today and give a short presentation on their work before we announce the winner. Subject to time, we'll be taking your questions and you can ask those questions via the questions box on the GoToWebinar portal. It's now time to introduce our first finalist, so I'll hand over to Niall English from Biosimulytics.
Thanks very much, Matt. So I'm going to be speaking today about crystal structure prediction and the broader context driving this of challenges in drug development and how we're responding to that at Biosimulytics, leveraging many advanced simulation tools, especially artificial intelligence and machine learning. So the spin-out Biosimulytics was first set up around this time late last year. It's got 3 founders. I'll speak about them in a minute, all of whom would have a combined total of over 65 years of technical, industrial and commercial experience. And our breakthrough really is in the prediction of the lowest energy crystal polymorphs of crystalline materials, notably pharmaceutical APIs, active pharmaceutical ingredients. And that really is our key selling point. And I'll talk more about the startup's unique selling features or unique selling points in a few minutes. But coming back to the heart of the problem that we're currently tackling, that is polymorphism. It's really a crucial problem in the pharmaceutical and drug development sector. And we have developed, in terms of a quick overview, some patents and IP that we've currently lodged and is at PCT stage with the European Patent Office for international filing, using artificial intelligence methods for exhaustive drug screening. We've won our first major commercial contract earlier this year, last January, and we're currently in Q4 this winter about to sign 2 further deals. We are currently undergoing an equity round of investment, a seed round of 375,000 euros ahead of an A round that we envisage in 12 to 18 months time, so that we can finish off validating our techniques in a commercial setting. This is after we have won 350,000 euros of national R&D funding from the Irish government in the past 2 or 3 years as we were spinning out. Briefly, to talk about polymorphism, drug API molecules are typically patented in their crystal state for actual manufacturing. But of course, there's a whole slew of potential crystal structures or polymorphs. They can be thermodynamically stable for minutes, hours, years, or they can be thermodynamically metastable. And that, of course, is the source of all the trouble. Something could have a long shelf life, literally sitting on the shelf, and then it could transform into an ineffective or possibly even harmful version or polymorph. Finding the right answer for the thermodynamically stable polymorph that will be stable for production is slow and painstaking and fraught with difficulty and uncertainty. And getting it wrong can be hugely damaging. I mean, let's look back at Abbott's famous case with Norvir, a particular polymorph, ritonavir. $250 million of lost income and, of course, lost time to market and sales because of a patent or a polymorph problem in manufacturing, which led to FDA and other litigation. Naturally, apropos the FDA and other national regulators and regional regulators, they, of course, have a huge interest in this and are really tightening up at patent filing level and also the IMPD filings for regulatory approval to produce. So there's a very large market in patent support and patent busting in knowing the correct polymorph. At the moment, today, all we have is the really problematic and painstaking experimental process of powder X-ray diffraction. And that can take many months, sometimes the guts of a year, to do a complete polymorph landscape analysis. And after all of that, we, and by we I mean mankind, we're still left scratching our heads wondering if we have actually found the most thermodynamically stable polymorph, and no one can tell for sure. I mean, there's cases of polymorphs still being found decades later after popular drugs and substances were first thought to have been fully known in terms of polymorphs. So this, in short, is a big problem. Now, what can biosimilitics do? Well, we have tackled the two big problems. That is, how to find the best force field, the best representation of the snacking of the molecules together, how to exert forces on each other. And the second big problem is, how do we search the whole patent landscape of different polymorphs efficiently? To do that, we've combined a combination of molecular chemistry, artificial intelligence, quantum physics, and of course, high performance computing, all meshed together in a type of a jigsaw. So what we take is effectively a simple two-dimensional structure that could be jotted down on a piece of paper or perhaps even a beer mat. And that way, by combining this jigsaw or cocktail of methods, we can generate an exhaustive list of all possible polymorphs, all potential space groups, and rank them by the most stable. And we've encoded this in patents, as I say, that we submitted to the British Patent Office almost 2 years ago, a year and a half ago, and now it's undergoing national international PCT filing, courtesy of the European Patent Office. In terms of our unique selling points, our competitive position in the market, we have a very fast speed and efficiency in narrowing down a list of polymorphs, something that takes weeks instead of months. We can mimic quite closely the state-of-the-art powder X-ray diffraction experiments, and we can deal with larger and more complex systems than current technology. We can also deal with water and hydration, because hydration of APIs is a very common problem as well. So we have a very impressive set of rather unique technologies encoded here that are very efficient. In terms of the founding team that has developed this spin-out, there's myself as the Chief Technical Officer. I'm a professor in chemical engineering in Dublin at UCD, but I'm an ex-industry drug hunter, if you will. I worked in the chemical computing group in Cambridge before, in the molecular simulation and drug discovery software arena. Peter Doyle, the CEO on the business side, is a very experienced business executive, especially in high-tech ventures. He was strongly involved in Baltimore Technologies as well, about 15, 20 years ago, and that big, great commercial success. And the technology lead is my close colleague, Dr. Burnham, who is an expert in the quantum modeling and artificial intelligence. Very, very clever man indeed. In terms of growth prospects and market, well, in the next, say, half decade, the next 5 years, the molecular simulation and molecular modeling market for material science, biomaterial science, is set to grow substantially from about $500 million these days, or I think it's about 600 million today, to of the order of about $1 billion by the mid-2020s. So this is something like 14, 15, 16% annual growth rates. And if you combine that over several years, you've got a very large market. AI, artificial intelligence, is a very disruptive entrant into this market that we have pioneered methods to reproduce very, very high fidelity force fields. And we can turn this in future into drug discovery as well, where we look at protein ligand binding. And I'm also a commercial expert in that, having worked in that R&D scene 14, 15 years ago as an ex-industry drug hunter, so to speak. Much of the crystal structure prediction and polymorph prediction remains in academia for now. So a lot of folk in academia are focused either on the search problem or the force field problem, but few tackle it both, grabbing both bulls of the horn, both horns of the bull, sorry, at the same time. So we are looking at this in a more global way. So there's a rather small number of commercial competitors in this space of polymorph prediction. I suppose to wrap up, I should give some outlook of our startup biosymbiotics plan for the next several years in terms of business. So at the moment in 2020, our projections have been slowed slightly due to coronavirus. But as I said, we did manage to secure one commercial contract last January, February, and we're in final negotiations for 2 more this winter. Then our growth in the next several years, next 2 to 3, 4 years, is based here in yellow on service contracts where we take the customer's API, as I said, written on a piece of paper or the said beer mat, and we produce the full polymorph landscape to complement powder X-ray diffraction. We're not talking about supplanting or removing experiments. Experiments will always be needed, of course, including the ability to handle chiral molecules that we also have, because many of the leading pharmaceuticals today are indeed chiral. However, to scale further the start of this commercial growth in the next several years, in about 18 months' time, we plan to roll out a software package. And this will be the second stage or phase of our growth, where we shall scale through software licensing, in addition to services contract where we are doing the polymorph analysis in-house. And this will allow for greater scalability and growth of the startup in the years ahead. So that is quite an exciting prospect. So at this point, I think I shall leave you. I think that I've said enough in the 5 or 10 minutes that I've had to give you a brief taste of what biosymbiotics mission is. Finally, I would like to thank Enterprise Ireland, who have funded the background R&D work in the past 2 or 3 years, and who are part funding the current equity seed round as we close that off in the next month or so, this side of Christmas. Okay, well, thanks very much for your attention, and good luck to you all today.
Thank you, Niall. We have a few moments for questions. So if you have any questions for Niall, please type them into the questions box on the GoToWebinar portal. While I give you a moment on that, if you have joined us for the Best Consultancy Award presentation, that will follow shortly after the Business Startup Award. So you are in the right place. We are presenting 2 awards this morning. We don't appear to have any questions for you, Niall, so we will move on. Thank you very much.
Okay, thanks very much.
Now time to move on to our second finalist, and representing Lixia, it's Jason Hallett.
Okay, excellent. Hopefully you can all see my screen, I hope. So I'm very pleased to be here today representing Lixia, and I guess I'd say very pleased to be here today, but since I'm at home, I guess I'm very pleased to be here virtually today. Lixia, like the previous speaker, Lixia is a university spin-out also, happens to be from the Department of Chemical Engineering at Imperial College. And I'll be talking a bit about our take on the bioeconomy. So the big challenges that we are trying to tackle are twofold. One is the growing push to have more and more bio-based or more sustainable products, especially chemical products and materials, and the growing amount of waste that's going into landfills or causing environmental problems through incineration. We are looking to sort of merge these two and solve both problems at the same time. There's a big push towards more and more second-generation sugars into the industrial biotechnology sector, and we're hoping to provide those sugars from very low-cost sources such as waste wood. The big problem with waste wood is that it's often contaminated, especially with preservatives that are used in things like construction materials, which are often heavy metals and very toxic, things like copper, chromium, and arsenic. So what we are looking to do is create revenue from that unwanted waste, and specifically revenue in the area of sustainable chemicals and materials, things like cellulose and sugars. It's a pretty big problem, or I guess a pretty big waste stream that we're looking at. If you think about agricultural residues, sugarcane bagasse, rice straw, wheat straw, all very famous for both their largesse and their widespread utility. But there's also things like forestry residues, and as I said, construction and demolition waste wood that goes into landfill. Most agricultural residues, of course, are burned, especially in the field, and this causes a lot of air pollution. And construction and demolition wood nowadays has to be sealed in specialist landfills in order to prevent the heavy metals from leaching into groundwater. So these create quite pervasive environmental problems that we're looking to solve. At the same time, of course, there's quite a big and growing market for renewable materials, especially things like cellulose. Cellulose, of course, is used in a lot more things than just paper. And while traditional paper making is on the decline, the demand for cellulose is rapidly on the rise, especially in the area of consumer products. At the same time, people are more and more looking into uses for the other byproducts of wood processing, such as lignin. There's a big market for bio-based resins. And as I mentioned earlier, the industrial biotechnology sector, especially in the bioplastics and even other areas such as biopharmaceuticals, are looking at creating a drive to move from first generation sugars to second generation sugars, specifically to get out of the competition with food crops. Our technology is rather unique in this space. First of all, we use ionic liquids as a means of processing wood. Our special, I guess our USP in the field is that we use very low cost ionic liquids. And this enables us to have a remarkable feedstock flexibility because we can handle just about anything that's thrown at us and still produce very high quality cellulose. We've been looking at a lot of different applications for these cellulose and developing in the areas such as dissolving pulp and micro and nanocrystalline cellulose for high-end applications, and also traditional sugars for things like biofuels and bioplastics. I'm a big believer in sort of, I guess, energy sufficiency when you're doing renewables processing. And so we have projected some of our lignin for high-end applications and some of it for energy recovery so the process can be energy self-sufficient. At the same time, because we're using an ionic liquid, we have the capability of valorizing all of the streams. We can make chemical derivatives from hemicellulose, and also all of those heavy metal preservatives can be recovered because we're using salts for the processing. And so each and every component inside the wood can be utilized, and in principle, this could be run as a zero waste process. It gives us quite a few advantages. I mentioned the feedstock flexibility. This is rather unique. We have virtually the same process with virtually the same outputs from hardwoods or softwoods. And as I said, pre and post consumer waste, agricultural residues, grasses, just about anything. This is quite useful for us because it means we're compatible with almost any stream. And so we're able to take in waste wood that at the moment isn't even fit for incineration. The lignin and cellulose are both quite high quality streams, and so we're able to valorize all parts of the biomass. And our biggest advantage, of course, is an economic one. Because the process is very, very simple, and because we're using a non-volatile solvent, we have a very low energy process, which gives us a very, very low cost production. We have quite a few partners, and we've gained quite a bit of traction in the area in recent years. Lixia was spun out in 2017, and so we're quite a young company. We're only 3 years old, but we've been working with big partners in Europe and in the Americas on applications for lignin and cellulose. Lignin, as I mentioned, for things like resins, and cellulose for a wide variety of materials applications, and even large-scale bioethanol production is currently under development. To date, we've raised about £4 million, most of which to build a pilot plant, which is set for construction next year. And we've had a lot of attention in the media, especially in recent years, including most notably a mention in Scientific American last year as one of the top 10 emerging technologies of 2019. Where we're at right now, so we've finished a lot of the proof of concept studies and our larger scale pilot trials. And so we're very excited to be constructing and operating our own pilot plant starting next year. We got some funding from the European Union in order to build that. And we are expecting to build our first commercial demonstration plant in about 3 years. So finally, as I said, it's a university spin out, but we've grown into quite a large team. Quite proud of it on a personal note, because I remember when it was just the 3 founders, they're at the top myself and Florence and Aggie working on this, and now we've sort of grown into a full-blown operation. And it's sort of nice to feel like a real company sometimes. And this is kind of it for me, but I did want to thank the European Investment Council, especially for the, we were very, very fortunate to get a €2.5 million grant last year to build our pilot facility, which we're hopeful will go online sometime in the first half of 2021. So that's the end of my presentation. Thank you.
Okay, thank you very much, Jason. Once again, if you have a question, please type it into the questions box on the GoToWebinar portal, and we'll just pause for a moment. Okay, we have our first question. Are there any advantages over anaerobic digestion other than the range of feedstocks?
Yes, I think the biggest advantage there is that we can make much higher value products, especially cellulose. Cellulose is well, actually, cellulose and sugars both are much higher value products than methane. So the biggest advantage there, I would say, is in the value that we can create.
Okay, thank you. Next question is, what is the final production rate of commercial scale versus the pilot?
I'm not exactly sure. I mean, I guess I should say it really depends on what the end product is. If we're talking about a biorefinery that's set to make cellulose for materials applications, probably somewhere around 100,000 tons a year. If it was set to make biofuels such as bioethanol, then it's something in the range of 100 million liters.
Okay, thank you very much. We're going to move on now, so thank you, Jason. It's time for our third presenter. So please welcome from Posidon Plastics, it's Martin Atkins.
Morning, everyone. First of all, let me thank the IChemE and the organisers for this opportunity to talk to you about it's Posidon Plastics, guys, not Posidon. I mean, it's an interesting interpretation, but we're Posidon Plastics. So our technology is all around PET, polyester recycling. So you know, in the industry, in the globe, the plastics have got a bad reputation in some sectors, and I think more recently, with all the trials and tribulations with COVID, I think plastics have really begun to show really where they are having a big impact and a big improvement in our daily lives. So the technology we're looking at is purely polyester recycling. The reason we chose polyester recycling as Posidon's core here is that polyesters reach quite a lot of sectors in our daily lives. So we'll come on to that a little bit later. There's an enormous amount of people and partners that we have to thank for support for this particular project, not least of which we're heavily indebted to Green Lizard Technologies at Teesside for their technical skills, their scale up and their fast track technology options. The Process Design Centre in Holland does actually a lot of the conceptual design engineering for this project, and really uses that to build technico-economic appraisal models for the technology to guide Posidon into the most economic regime for plastics recycling in our case. So the chemical engineering challenges are quite enormous with this waste. So if we just go on to I'll just move on to the next slide. If the computer works. This is a slide where we're just going to show the if you like, the breadth of the circularity on PET plastics. So if you go from left to right, you'll see in the middle the polyester wastes that typically appear in municipal waste or industrial waste range from everything from your white water bottles to Coke bottles, Pepsi bottles, microwave trays, shirts, fabrics, and packaging films for your sandwiches and so forth. Traditionally, they would go into waste. A large part of that today is put into landfill or incineration. A lot of the clear materials, like your water bottles, are actually mechanically recycled. So there they tend to wash, sterilize, chip, and then remelt into materials. But mechanical recycling, of course, is very limited. They have an average life of about 5 times in circulation before they lose their mechanical stability and mechanical integrity. So the technology that we've developed is actually in the bottom half of this slide. It's an enhanced recycling process, so it's often called chemical recycling process. And here we drive the waste PET back into a monomer, which for those of you with chemistry interests and background, you'll see the BHET is the monomer for virgin PET production as well. So we take all of those wastes and we make them back into the monomer, which goes back into the virgin production. So you note virgin production above there is actually all from hydrocarbon sources at the moment, or a large part of it is. So the engineering challenges that this type of process engenders is, how do you process all the different types of waste and all the contaminants that are in that process? So the primary process we use is something called glycolysis. And it's whilst the chemistry is very simple, from a chemical engineering point of view, being able to prepare the feedstock in the right quality, the right size, the right form, and then being able to take out all the co-products, the byproducts, the nasty contaminants in there, all the heavy metals and so forth that are present from those particular wastes, and then produce a water white BHET monomer for recycling, are quite intense. And one of the other things that about this technology, which is why we've worked with the Process Design Center and Green Lizard so closely, is that the conceptual design actually really drives us on the most economic route. So there is no point doing a technology for the sake of the technology. It has to be able to make money. It has to be giving good returns. So we've spent a lot of time with the Process Design Center and Poseidon optimizing the flow sheet, optimizing the technology, and moving forward there in a competitive way to be competitively priced against virgin material. I'm very pleased to say that only a few weeks ago we were awarded a UK SSPP grant, 3.6 million, for a consortium in the UK, which is helping us with the demonstration of the UK's first enhanced recycling facility here at Teesside, which is a 15,000 tonne a year plant. So that includes the whole supply chain. Is public domain information. You can check that information out. It's a whole supply chain from Biffa supplying the waste. We work with 2 PET producers up here, Alpec and DuPont Taijing. We have O'Neill's and GRN that have got very strong interest in recycling fibers to make sure they can get the circularity of fibers. So it's a very ambitious consortium. It's a consortium driven to get the first commercial plant. Poseidon has quite ambitious plans itself. We're building a 50,000 tonne plant once this 15,000 tonne is proven, and then we're rolling this out across the globe. It takes about 2 years from release of capital to build our plants, so we will be just in time for the upcoming European legislation, which is going to be a tax on companies that are not abiding with recycled content in the plastics. So I'd just like to move on to a little bit of the technology for those of you that are interested in really where the complexity comes from in the recycling process. The chemical engineering has been quite interesting and exciting, as all chemical engineering is these days, when you're applying it to problems that solve our global issues. But you can see there that we take The waste material, the waste polyester, we have a proprietary catalyst system that we manufacture ourselves as well. We run that through the process. You have to go through various steps then in this process to take out the different contaminants. When you're dealing with waste, no matter how good you are with the separation and purification of the waste at the front end, you never remove all of the contaminants 100%. So a lot of those things go through the process. And that's, as chemical engineers, we really have to make sure that we've got everything removed from the process that needs to be removed to meet the product in specification. So we do filtrations, we do separations, we do other purification steps, and we make this BHEP monomer, which goes back into virgin production. For those of you not familiar with the polyester industry, the feedstock purity has to be really high. It's greater than 99.9% purity for the feedstocks. So the chemical engineering challenges from waste are really quite difficult and really been quite challenging at times. And that's why we've needed all the partners that we work with to get this process running. We recycle everything we can in the process. We kick out very minimal amounts of waste here. Energy integration is key, and feedstock integration is key. So if we just move on to one other issue as well, because I'm sure it does come up. It's come up in a lot of our investment discussions as well. Is what is the carbon footprint and the life cycle analysis. So I'm not going to dwell on this slide. We've put the references at the bottom there if people want to follow those up. But basically on that first slide, if you look at the footprint for virgin, which is taking all the feedstocks from hydrocarbon sources and then making polyester products in the final product, you'll see that it's got about 4.6 equivalents on that slide. If you look at the mechanical recycling, which is just the white water bottles that I've mentioned before, see that is a low number, but it's actually a very limited number of recycles you can put in that process, and it will not provide the full circularity that the businesses or the brands need in order to meet A, the legislation, and B, the demands in the market. So our enhanced recycling process is on the right hand side there. So you see it's nearly half this carbon footprint of the virgin material, so a significant improvement on that technology. And I'm looking at the time now, conscious of the time. We'd just like to thank all of our partners in this supply chain that have really made it possible for Poseidon to be where it is today. We really like to thank the sponsors and the investors and shareholders in Poseidon, which is Abundia and Panama and Green Lizard. So just huge amounts of people to thank, and not least of which the technical team here at Teesside, which have done a fantastic job in getting us to this point and taking us to the 15,000 tonne a year plant, which will be starting construction early in the new year. So thank you very much, everyone, and happy to answer any questions.
Okay, and thank you, Martin, from Poseidon Plastics. We will just pause for a moment then. If you have a question, please type it into the questions box on the GoToWebinar portal. Well, I'll give you a moment on that. Let me remind you that this is one of a series of IChemE Global Awards webinars taking place throughout November. If you'd like to find out more about what's still to come, visit icheme.org/global awards. That's icheme.org/global awards. Right, we don't appear to have any questions, so we're going to move on. Thank you, Martin. It's now time for our last finalist in this category. Representing the University of Hong Kong, it's Tony Feng. Tony, if you're still getting yourself ready, that's fine. But if you are talking, we can't hear you. You will need to unmute yourself.
Yeah, Okay, can you hear me right now?
Yeah, that's perfect.
Okay, yeah. So, okay, sorry, I'm Tony from Hong Kong U. So our company, we call High Performance Solution. It is also the university spin-off company. So so today I would like to share our project, direct thermal charging cell for converting low-grade heat to electricity. So actually, we invent electrochemical system. So we call direct thermal charging cell, so DTCC. So we use graphene oxide and platinum nanoparticle as a cathode, and use a conductive polymer, polyethylene, as an anode. So and then we use the aqueous redox electrolyte. So basically, our performance, as you can see here, compared to other devices, we are the best so far. And we use a pouch cell as our package. So we file a patent and also publish a paper. So there are 3 operation stages in our DTCC operation. So in the beginning, so there are building voltage because of the anode and the cathode, the electrochemical potential difference. So at stage 1, so when we heat up, so graphene oxide will have a thermally induced pseudo-capacitive effect, so it will generate the voltage. And this voltage can be further boosted by the redox couple in the open circuit. So when we connect the cathode and the anode together, so basically the voltage can make the polyethylene being oxidized and release a lot of electron. So this electron can be carried by the redox couple. So after discharge, so the reaction stops. So, and the interesting thing is that we found once the reaction stops, we reduce the temperature. So in the low temperature, so the iron 2+ and the polyethylene, so they will have a catalytic reaction. So this is automatic reaction. So the iron 2+ can back to the iron 3+, and the polyethylene can be reduced, so back to the original status. So and then we can make it for the next cycle. So as you can see here at stage 1, so for the thermal charging, we use a graphene oxide. So this can have a good thermal pseudo-capacity effect to generate capacitance. So our thermal response is about 5 millivolt per Kelvin, so which is quite good. And this is because of the functional group of the graphene oxide. So as you can see here, the chemical reaction. So it can make a thermally reduced, induced pseudo-capacitive effect. So for the electrical discharge, so we heat up at the open circuit, and then we can do the discharge and release a good amount of electricity. So for the operating temperature, so basically our temperature has to be over 30 to 40 degrees C, because we have to make the open circuit voltage higher than the onset voltage of the polyethylene, and then we can make the polyethylene being oxidized. And then for the upper limit is because we use liquid electrolyte. So basically we have a good operating temperature range in the low-grade heat range. So from the 30 degrees C to about like the 90 to 100 degrees C. So as you can see here, so at stage 3, so basically we call it is chemical regeneration process. So after the open circuit heating, we generate the voltage and discharge polyethylene being oxidized, and redox couple iron 3+ become iron 2+, and then when we cool down, so basically the oxidized polyethylene will react with iron 2+ in the acid environment to make the polyethylene being reduced, and the iron 2+ back to the 3+, and then we can make the this system to running for cycles. So as you can see here in our lab, we can make 20 cycles, but in the company right now we can make over 500 cycles. So this is good for the commercialization. So as you can see here, our performance basically we are the best as compared with other devices in the low-grade heat region. So compared with commercial solid-state semiconductor thermoelectric material, so basically we have we are cheaper and we are bendable and lighter. So, and then we have a good efficiency at the low-grade heat region using the temperature cycle rather than temperature gradient. So we start a company called High Performance Solution, and that's supported by the Hong Kong government for 3 years. And also we are select to enter the Hong Kong Science Park. And now we also finished first fundraising, and now we have a few customers, as you can see here. So we also enter, attend many entrepreneurship competition, and also win lots of awards and attract many investors' attention. So, and now we have 3 major industrial partners. So first is the HVAC company in Hong Kong. So as you can see here, so our idea is to recover the waste heat from the HVAC system, for example, like the compressor. So, and then we can generate electricity and recycle this energy. So the second industrial partner is in Taiwan. So we are thinking to integrate our device into the smart window system. So as you can see here, so this is our lab demo. So basically we integrate our DTCC into the window frame, so we can absorb the solar heat and make this solar heat become the electricity. So this electricity is good enough to power the electrochromic window. So we can make whole electrochromic window as an off-grid system. So, and the third partner is in China. So the Shenzhen EcoFlow. So basically we are thinking to recover the body heat and then to power some sensors. So as you can see here, so this is our lab demo. So we use our device and touch the human skin. So as you can see here, we can generate good amount of energy. So this energy is good enough to power many low power consumption sensors. So now we already make our prototype flexible DTCC product and then try to integrate into the wearable device. So right now our business center is in Hong Kong, and we set up our manufacturing line in Taiwan because we already have the funding from the angel funding. So as you can see here, this is a 10K clean room, and then this is from phase 1 and all the way to the, this is our final production line, and we have the 200-liter mixing tank to make the slurry, and this is our module product. Now we are produced to our customers. So right now, in this year, we make the first revenue about 2 million Hong Kong dollars because of the smart window and some electronic applications. And the Q2, we set up our the demo and our product in the Hong Kong EMSD. So this is the government sector. And also we signed NDA with Tongpo. So it is a listed company in Hong Kong for product development. So they are working on some home appliance. So, and yeah, thanks for your attention. So this is our team. So right now we have, we are a spin-off company from the university. So right now we have CEO, one CEO is my student. So it's a Vivian, so in the middle, and 4 engineers. So we have some academic partners, industrial partner, and the customers, and also some business partners. So thanks for your attention. So this is the end of my presentation today. So I'm glad to take any questions.
Okay, thank you very much, Tony. So as Tony says, he's happy to take questions. So if you have got one, please type it into the questions box on the GoToWebinar portal. We will just pause for a moment. Okay, I don't think we have any questions, so thank you, Tony. We will move on. So it's a big thank you to all four of our panelists. Thank you for presenting today, but it's time to reveal the winner. So we start with our highly commended entries, and they are the joint entry from Poseidon Plastics, Green Lizard Technologies, and the Netherlands Process Design Centre, and Biosimulitics. So well done to everybody associated with those entries. But now for the winner. Ladies and gentlemen, the winner of the IChemE 2020 Business Startup Award, sponsored by the Chemical Engineer, is the University of Hong Kong. So well done, Tony. Congratulations.
Yeah,
if you can
thank you. Yeah.
How does it feel to be an IChemE Award winner?
Yeah, thank you so much. Yeah, so this is a really exciting. We can win the award because yeah, we just started the business, and then we this award certainly will bring us to more attention, so probably more investors. Yeah, thank you so much. Yeah.
Well, thank you, and well done to all of our finalists. We're now going to move on to our next award presentation, and this is the IChemE Best Consultancy Award, sponsored by the Chemical Engineer. This new category recognises the individual, organisation or group that best demonstrates the provision of outstanding consultancy services within the chemical engineering community. Here are our finalists. We start with ABB Energy Industries, Barberton, Engineurs, Marsh JLT Specialty, Renatech, and Worley Group. So once again, we'll be inviting all of our finalists to give a short presentation before we announce the winner. And first up, representing ABB, it's Alan D'Ambrosio.
Okay, good morning, everyone. Is the slides visible, Matt, on the screen? Because I've got two monitors.
Not yet. You should have seen a button appear on your screen which says, I think it says share screen, something like that.
Okay.
There we go. And if you just put the display settings so that we see the other view.
Okay, is that better?
We're still seeing your presenter view at the moment. So you've just got up to the display settings option on the top left.
Okay, I think that might be it.
That's it, perfect.
Okay, all right. Good morning, everyone. So my name's Alan D'Ambrosio, the Market Development Manager in ABB. So I'm delighted to be here this morning and to be presenting ABB for the Best Consultancy Award. So I'll take you through some of the work we've done over the last 2 years, which we believe put us in for this award. Okay, so ABB Consulting Services, we've come from ICI, so we were part of ICI. So we come from a strong chemical engineering company with operations globally. We were acquired by ABB in 2001, and we work predominantly in the energy industries, started in the petrochemical and chemicals, but work in the oil and gas, pharmaceuticals, and all the remainder of the energy industries. And we based out of the UK, so we have offices in the northeast and northwest of England, where the petrochemical hub of the UK is, but we actually work across the world, supporting customers around process safety, but also looking at how they make their operations more sustainable. And you can see on the top left-hand side is our services. The process safety is one of our key services in there, but we also have integrity management, reliability. We have a very strong process engineering.
Hello， 他对他当场就公布了，对他当时我还在那个。
Sorry, can someone else mute, please? Okay. Okay. What we did realise about 2 years ago is the market for in the energy industries and for consultancies was changing very rapidly, and we needed to change with that market. So we had very clever people, we had experts in each of the areas you can see on there, but actually we were in a very fast changing market. So we came up with 5 themes of where we wanted to move in as ABB. We wanted to create success for our customers, and we wanted to be able to scale what we do. So we're based out of the UK, but we want to be able to scale outreach across the globe, but also to collaborate within ABB and with our customers. We want to be different in we can help transform industries, because as well as the challenges for ourselves, we see very big challenges for our customers in oil and gas with the low oil price, in chemicals with a fast moving market. Sustainability, obviously, it's all around us, and technology is becoming much more important, especially digitization of the world. So we wanted to get all 5 of those key themes in there, and you'll see that through how we've taken that on board. The bottom just shows we actually work with our customers from a concept, a new greenfield plant, to actually building the facility, to actually sustaining and operating the facility. And unfortunately, a lot of the time is into decommissioning the facilities. So we work across the whole life cycle of operations. So you saw the traditional products, and we knew we had to change. And one of the big areas we had to change was how we bring digitization into our offerings, and also technology into our offerings. And so suddenly we had a lot more different options that weren't there 2 years ago. You know, the big changes, remote insight is our ability to work in different parts of the world, maybe without traveling, using HoloLens and different technologies, so we can actually be on a customer site without mobilizing people. And we're actually using that, and we're using that in one of the examples you're going to see at the moment. Edge Insight is where we can actually stream customers' data and actually know how equipment is performing before the customer knows how it's performing, and we can actually intervene into issues. So we can actually drive our consultancy before there is an issue on plant. So we've got that, and then you'll see these orange boxes are all software offerings we actually put in. Safety Insight is the digital HAZOP. So we've gone from the traditional HAZOP you'll see to a digital HAZOP and so on. So we've driven a whole amount of technology into our offerings in the last 2 years. And I'm going to go now into what we've actually done in 2019 and 2020 to embed that technology in work we've done with customers. So the first example is with MOL Group. So MOL is based out of Hungary. They are an oil and gas. They've got petrochems and refining facilities, and we actually set up a contract with them right at the start of this year, looking at how we actually deliver change across their asset integrity on 4 of their facilities. So we've got facilities in Hungary, Slovakia, and Croatia, where all their downstream elements in. So we're working in 4 different languages. Their 3 languages in English in there. We're bringing a whole set of digitization and technology into what they're doing in there. And we're working with a third-party provider as well, a Canadian company called Integrity, that's providing a single software suite that we deliver in there. So bringing this, unfortunately for this is one of the jobs we've actually got approval for the customer to be able to publicize. And you'll see there was a press release on this a few weeks ago, so I can name it. So with that technology is we're able to deliver 10 million euros of production improvements across their facilities per annum in there. Improve their mechanical integrity and safety, so the process safety of the facility, increases the availability. And actually one of the areas we want to really do is how do we actually make the large maintenance events the target world we're living in at the moment. The second example is in Kazakhstan. So this was the start of last year. It's an old refinery, 25 years, 30 years old, and we've gone in as ABB in collaboration with ABB China and actually digitized their refinery. So before we came in, everything was in paper format, and this is a multi-million-dollar spend around digitizing their refinery. And as with the first one, the main expertise has come from our offices in ABB in the UK. So we're leveraging our capability in the UK, and we're providing that global reach. The really good thing in this project is this has got very strong oversight by the Kazakhstan government. They have a program called Digital Kazakhstan, and this enables us to actually bring their plant up to the 21st century, but actually make them as good, as highly efficient as any refinery you will see in Europe in there. So working across 3 different ABB countries, ABB China, the UK with a technical lead from a consultancy perspective, and ABB Kazakhstan will provide some support on the ground as well in there. And you can see who the client is. And this fundamentally changes the client's performance. They've gone from a shutting down every year to a 3-year shutdown and a lot safer facility. The last big job I'm going to talk about, and I think is the most interesting for me, and the first 2 you've talked about is brownfield, is this one. So this is one of the largest investments in East Africa, largest in this country. I can't name this one. This hasn't gone. We don't have approval to name it. A multi-billion-dollar expenditure. There's 3 EPC contractors working on it with one of the large oil and gas majors in there, but all the process safety design for this is being done by ABB. Process safety design verification for this is being done ABB from our UK offices. So we are overseeing all the process safety design from the EPC contractors, the outputs of their design, and we are validating that. And by doing that, we ensure the design is correct, it's going to be safe, and we can start the plant up with faster commissioning, safer startup, and safer operations. So with the end operator, we developed the methodology for verification with them a long time ago, and this and that from the history of previous greenfield projects where design issues went through into operations and incidents happened. This is about eliminating incidents on large greenfield operations. So again, a big global reach, and this project was started in 2019, but actually first gas and LNG is not till 2024. So it's a long time span project. So back to our transformation, we talked about the scalability and reach. Hopefully you'll see that, we've got that in Hungary with MOL, we've got the LNG in Africa in there. We're working in collaboration with many different partners. We're transforming industries, in Kazakhstan, we're bringing a refinery up to the 21st century and making it as competitive as any European. With MOL, exactly the same. We're underpinning the performance. And before we came in, some of these plants were shutting down. If anyone knows, in the UK, we've seen a lot of refineries shut down. This is about underpinning the performance of these facilities. Embedding sustainability. This isn't just about ABB going in and delivering a piece of work. So with MOL, we've actually signed an agreement where we actually have knowledge transfer. So we're teaching them how to actually do the works. So we've developed the framework for doing the work. We then actually show them, we call it show, where we do the first couple of units for them, and then teach and coach their staff, and then we support and verify what they're doing. Very similar around that with the verification on a large project, and we maintain a strong industry knowledge. We have a huge suite of training, lunch and learns, webinars in there, and we're developing and empowering both our people and our customers' people in there. And I think the main thing for me, I've been in this role for 2 years. 2 years ago, we were using very little digital technology. We've gone into all of these offers are using technology. We're able to work across the world. And all of these contribute to creating success for our customers, because that's what keeps us profitable in there. So last couple of slides. With all of this, so a lot of these jobs were won in 2019 and the start of 2020. We're seeing unprecedented challenges in the business world, in the energy industries and the chemical engineer around COVID, around our ability to travel and support. But actually, in ABB, we've actually taken that brings a lot more opportunities as well. It's made the world smaller. We're delivering a lot more jobs remotely. So we've done an offshore process hazard review in the North Sea, totally remotely, where initially we were going to do it as face-to-face. We've done alarm rationalization in Qatar, again, remotely. In the past, the customer just wouldn't have entertained those things being done remotely. A lower cost, faster, and the quality is exactly the same. And it's accelerating the digital transformation you've just seen in there. So where's that left us in 2020? So these are jobs that have gone through in 2020 around rising to this challenge we've got. The first project was the one I've just mentioned. It was a process hazard review, a hazard type study in the North Sea. It was scheduled to start right at the start of lockdown 1, as we had in the UK. When we just couldn't travel to customer sites or it was very expensive, we actually took the decision with the customer to do it remotely. And what you're actually seeing is a snapshot from their intranet. So they actually, we've completed a study, it was very successful, and they put it on their intranet to say how well that's gone, and the breeds of success. The second job was for one of the large power companies in the UK. This is about ABB transitioning into renewables. It's one of our very large projects going into renewables. So hopefully around sustainability for ourselves, but also looking at the new industries that are coming out, the hydrogen industry, renewables industry, and how we transition into that. That project started in June. It's about us upskilling the operator and getting more on the operations and the reliability of their performance. And I think one of the biggest successes this year was, and all our focus is in the US at the moment with the elections coming out as they speak. So this is in Louisiana in the US. It's a chemical company in there, and we're actually conducting an asset life study. It went out to competitive tender. We were bidding. We were the only UK company bidding on it. Everyone else was US, but it shows the strength of UK chemical engineering and UK engineering in total. That we could actually win with COVID job. That's a very significant job that's going to take us 9 months to complete with all these challenges, and we're doing it. And we've built technology around it in the delivery. So for me, very, very proud. Last slide. We have risen to the challenge. I think a lot of those jobs you've seen over the last 2 years, we weren't seeing those before that. We've transformed ourselves, brought digital in there, and I think we've managed to overcome a lot of the COVID challenges. And as you've seen from the last slides, actually look at how we actually gain benefit as well from some of the changes in the market. Based on these 4 big values in there, maintaining our unrivaled expertise, but actually, how can we call it smarter thinking, but how can we get better solutions for customers? Because we believe every dollar the customer spends with us, we actually need to translate that back to $10 in benefits for the customer. And this is the smarter thinking to give them the most optimum solutions. We want to work with customers all the way through their life cycles, and we want to empower both our people, but also the customer's people through training, coaching, mentoring, to make sure, you know, all the benefits we have are our people and our customers' people, and the collaboration we can have. Okay, that's the last slide. Any questions?
Okay, thank you very much, Alan. So once again, if you have a question, please type it into the questions box on the GoToWebinar portal. We have our first one under the section for sustainability, under transitioning into new industries. Do you have some further examples?
Yes, so we have set a team looking at hydrogen in there. So we are actually working on some hydrogen projects at the moment. Renewables is an industry we've actually just secured our first large project in there this year. So we're looking in biomass, again, something we weren't doing a year and a half ago. So just looking at, you know, as people can see, a lot of the oil and gas is very stretched. The LNG Africa is one of the rare examples of a large oil and gas multi-billion-dollar project that's gone ahead. And what we've looked at is how do we bring our chemical engineering, process engineering, and mechanical engineering skills and make them powerful in there. And as we've gone through that, we've actually realized a lot of the skills that we've got traditionally actually are transportable into those new industries, and we are seeing successes in there, and hopefully by this time next year we'll see a lot more successes as we, you know, as the hydrogen industry grows globally, and we work with different parts of ABB as well in pulling that.
Okay, thank you very much, Alan. It's time to move on. So thank you for your presentation. It's time to move on to our second finalist, and from Barberton, please welcome Louise Whiting.
Hello, everyone. Thank you very much to the IChemE for this opportunity to present on the awards panel. So my presentation is relatively simple. I didn't want to bore you guys too much with too much detail. My entrance was mainly around my process safety awareness campaigns that I've been running through LinkedIn and on YouTube. I've set up my company in 2019, and obviously then COVID hit, and it has been a really exciting and different time to be setting up a company than I probably would have imagined when I started the company in December. I have over 11 years experience in operating companies, which means that the service that I provide is very practical. When I deliver workshops, I have a lot of repeat business because when we go through the workshops and we develop action plans, the action plans are very practical and can be delivered, because I have a very strong experience in that area, delivering process safety on large sites throughout the world. I've also developed a series of technical articles, which you can also find on my website. These range from Process Safety Storm, which I wrote in April, which unfortunately is starting to be realized, to HAZOP, loss of containment and intervention activities. Starting this month, we'll be looking at a new series of articles, starting with failure to learn. And that's run through what we do is a process safety forum. So one Wednesday a month, we get together and we talk about process safety for 1 hour. So it's the sessions are structured really for the attendees. We have 10 minutes where we will have a look at the topic, so give a brief introduction, and then after that the floor is open for question, and we have had really good engagement on this throughout the last 2.5 months. Now we're going to go sort of looking into more embedding learning. So what we've been doing is we've been running the process safety forums once a week, but I found that we're changing topics so quickly, people aren't getting a chance to embed their learning. And that's why the first topic for the month is failure to learn. We'll be looking at repeat incidents throughout the industry, and then how we can start embedding our learning. To be able to support that, I've also developed a masterclass. There's also a lot of free information or tools available on my website, like a HAZOP action sheet, HAZOP audit sheets. And then you've got the masterclasses here for the next 5 months coming up. If you want to find out more about what we do with regards to the process safety communication, or if you want to get in touch with regards to any of my communication, you want to take my services on anything, just get in touch on LinkedIn is the best way, or you can go through the website. But have a look out for this group called the Process Safety Forum. Our next event is actually tonight, and we've got really lucky to have Nick join us discussing functional safety. And then finally, if you missed anything, or this is the first you're hearing of it, and you want to catch up on anything, on the YouTube channel is all the videos available with all the process safety forums there, and then also a series of videos I did on McKinsey report and some others on HAZOP. So feel free to check those out. And yeah, so if there's any questions now, feel free to ask questions, and I'm happy to answer them.
Okay, thank you, Louise. So once again, if you have a question for Louise, please type it into the questions box on the GoToWebinar portal. While we wait for questions, it's a suitable time to thank our judges. Our judging panel are all volunteers, led by our head judge, Keith Batchelor. They review and score all of the entries across all of the categories, working very hard over the UK summer every year. You can find out more about the judging panel on the IChemE Global Awards web pages. Right, I don't think we have any questions, Louise, so we're going to move on.
Excellent.
Thank you very much. It's time to introduce our next finalists, and from Engineurs, it's Alex Howard and Richard Freeman.
Right. Hopefully you can see my screen.
We can see you at the moment, Alex, but not your screen.
Okay. 2 seconds.
There we go. Now we can. Oh, now we can't.
Let me know if you can see it again.
And now we can again. Yeah. Okay.
Wonderful. All right. Well, thank you very much for your time. So introducing Engineurs. We are a consultancy that is really focused on developing the future sustainability and the green nature and a prosperous future of our energy security going forward. So hopefully Richard is online to talk us through our first slide.
Hi, can you hear me?
I can hear you.
You can hear me, okay, hi. So just wanted to introduce myself first. So I'm Richard Freeman. Set up the company Engineurs with Alex Howard. I've had 30 years in the chemical engineering industry. Alex has had about 20 years in the chemical engineering industry. We both started as process engineers. We then went into operations, and we've both done commissioning and startup. We've operated in Europe, Asia, and Middle East. And as a result of that, we have quite a large network of professional engineers. We both have some personal objectives, which is to give back to the chemical engineering sector as well as society, and we want to leave a legacy. So earlier today, we heard about people talking about global challenges, and for us, you know, the global challenges, of course, are call to action. We were looking for a famous quote, and thought it was very appropriate that we chose today Barack Obama, being a former president of the United States, and he quoted, "Climate change is no longer some far-off problem. It is happening here, and it's happening now." We all feel, though, we still have time to halt and even reverse the damage that we have caused to the planet, and we have a responsibility to act. Back to you, Alex.
So with that in mind, when we set up Engineurs, we really wanted to focus on what we could do with the learnings and our education and the background and the network we had, is how could we really affect that and be part of the sustainable, greener, more effective future. You know, we've been talking a lot about petrochemical industries and activities like that, so we really wanted to know how we can be part of the green revolution going forward and supporting our larger clients in their energy transition, their decarbonisation, their existing processes, and how to integrate or to switch to developing technologies. So we started to really become experts in those technologies, merging different groups together for mutual benefits, because often you'll find that within green technologies, there's power within different groups together to have a complete network of a sustainable future for a total green economy. And so we've been very much part of that and looking at how we can integrate different decarbonisation calculations, and also by looking at how we can meet the regulatory exist, especially with the 2030 and the 2050 targets that have been set. And then the technologies and the areas that we have developed and become experts in over that time is really looking at commercial scale green hydrogen and electrolysis. We're looking at helping decarbonize the LPG sector, which really is off-grid power or energy. We've been looking at how part of the total energy solution, you can't just have wind farms and solar panels, because at night it's not a lot of sun and it's not always windy. So part of that solution is really finding how to stabilize the network without the gas. And so, you know, we've been working with the largest cryo battery storage company that cryogenically liquefies the air, stores that as effectively as an energy battery, and then discharges that through expanders and recovers the energy when the grid is requiring the balancing. Plasma gasification, done a lot of work on that, predominantly on waste to energy, and now supporting some fairly significant projects on doing waste to jet fuel. Biomethanol products, which was really interesting to hear some of the discussions on the wood pulse and creating ethanols and sugars, because that can be part of the biomethanol transition. Household waste to jet fuel we've talked about, and carbon capture and sequestration storage. That's often part of a grey hydrogen solution that we were looking at previously, and very much so we are trying to support in the decarbonisation of the existing assets by looking at CCS systems. Some of the flagship projects that we're very proud of so far in 2020 is with UGI International, one of the largest LPG suppliers in Europe. Have an enormous carbon footprint today, and really they weren't very far, and they won't mind me saying this, in terms of their decarbonisation roadmap and planning, And we've come in as their major consultant and really working as the owners engineers to help them with that roadmap, help them with the technologies that they weren't fully aware of, linking them with some of the jet fuel projects and some of the other players who are trying to make biofuels, and combining them together to try and really get a mutual benefit out of how those processes can be linked together. Just as historically, the waste of the oil and gas industry was typically LPGs that they could sell, whereas now we're trying to integrate them as part of that green technology, the biofuels, and that's a massive transition for us. And so for us to be part of supporting and engaging and really driving that change to 2030, that represents over 13 million tons of CO2, and by 2050 that would represent almost 40 million tons a year of CO2, and that's an enormous amount of decarbonisation. And as a company the size of Engineurs, we're feeling we're really punching above our weight by being able to be part of that roadmap and that transition and supporting large companies like UGI get there. We've also been awarded the contract, and I empathised with ABB earlier today, not being able to give names, but I can tell you that they're the world's first commercial scale cryo battery for the grid balancing, and we are doing all of the on-stream planning, the commissioning support for that, because we have a lot of cryogenic experience, and it merges well with our environmental targets and our remit. So I thought to myself, putting in a slide, why we think we are applicable for an award such as the Consultancy of the Year. We made some pretty enormous steps since we first got started 5 years ago. Last year we were highly recommended for Business Start of the Year, and we really feel like the recognition from a society such as the IChemE really helps us to invigorate greater change and really to become even more integrated with the solutions that are coming forward. It helps us in being able to get the recognition with our clients, and it really puts us in a position where we can make an even greater impact. And what that does is it really sort of sets out for the IChemE and for the committee members, the panelists, to say, what is the passion for the support of companies like ours that we want to really endorse going forward? Do we want to really endorse existing technologies, brown technologies or grey technologies, or do we want to be really sort of championing the change that needs to happen? Linking back to the original slide that Richard talked about, the time for change is now. By supporting companies like Engineurs, you are supporting that change. Thank you for your time, consideration. Myself.
Okay, Richard. Thank you very, very much, Alex and Richard. Once again, we'll pause for questions. So if you do have a question, please type it into the questions box on the GoToWebinar portal. While we give you a moment on that, if you have been suitably inspired to submit your own entry to next year's IChemE Global Awards, keep an eye on our website for entry details. We typically open for entries at the start of March each year, so head over to icheme.org/global awards for more details. We do have our first question. First question is, what were the biggest challenges getting started and how did you overcome them?
Do you want me to take that one, Richard?
Yes, by all means.
Okay, I think initially it's finding the right contacts, and so there's a lot of different technologies being developed at the same time, and we really focus on trying to become experts in as many as the ones that were going to be successful as possible. And so really, I would say the hardest thing is you can't become a consultant and an expert in every technology that's emerging today. And it's really understanding the ones that have the most promise for large-scale decarbonisation and finding the right partners to be able to talk to. As a small startup, it's difficult to get in the door sometimes, and you really need the first couple of recognition projects to be able to say, we belong in this sector or field. And so we feel like the first couple of years of developing was probably the hardest, and I guess the way to get through it is to really just keep going and to make sure that you're doing something you're passionate about, and that passion comes through, and then other people can get on board with what you're trying to achieve.
Yeah, Alex, I totally agree. It's been very hard to get recognized for our skill sets when we are starting off as a small enterprise, small organization of professional engineers. But as you say, it's through word of mouth that we have started to make inroads.
Okay, thank you, Alex and Richard. We're going to move on. So thank you for your presentation. We now move on to our next finalist from Marsh JLT. It's Nicholas Holland, Zaid Lafter, and Marine Botha.
Hello, can you hear us?
Yes, loud and clear, thank you.
And can you see us? Can you see the slides?
Yep, we can see you and we can see the slides.
Excellent, good stuff. All right, hello everyone. I'm so glad you can join us today. We're most grateful to the Institute of Chemical Engineers for including us as first-time finalists at this year's Global Awards. My name's Nick Holland. I'm joined by my chemical engineering colleagues today, Marine Botha, as well as Zaid Lafter, to share with you our consultancy story, as well as to answer any questions that you might have. So let us start with an exciting introduction to our risk engineering consultancy team. Marsh has been providing risk management and engineering services to the energy and power industries for over 40 years. We have a collaborative engineering workforce positioned in hubs across the world, and today our presentation features experiences and case studies from our Middle East and Africa risk engineering team. Our Middle East and Africa team includes now 19 professional engineers, with 2 new joiners in the last couple of months, located within the United Arab Emirates, Saudi Arabia, India, as well as Bahrain. Between us, we represent around 10 different home nations, and each of us brings different diverse professional industry expertise to our clients, as well as our colleagues at Marsh. We're very active within our region, and over the last year, we surveyed around 200 process plants for operational risk quality, as well as production planning re-optimization surveys. We get to work with a broad range of operators, including national as well as international companies. We help out and support as well a number of independent single-site operators, and they may often sometimes miss out on the benefit of, say, a wider corporate governance that you'd see within a major corporate presence. Since joining Marsh in 2016, I myself have found kind of a feature that has been rather professionally stimulating for me is a challenge of working with such an enormous range of process technologies, many of which in this part of the world are truly at a world-class scale of production. Through participating in this event, we found this to be a great opportunity to reflect on our recent achievements, as well as our industry impact. We're very proud, and we're proud to be the trusted advisors for replacement capital, as well as free cash flow risk exposures in excess of $200 billion each year. And our advice is used by energy and power operators to transfer these risks, and the risks can be quite high, sometimes as high as much as $8 billion per single loss event, transfer those over to insurable products. When we service our clients, we very much like to focus on 3 key attributes. Number 1, we blend our chemical, mechanical, electrical, and construction engineers to provide a complementary service. Our team of experts, we all work together to support our clients' objectives and improvement plans. We drive to have 2 to 3 engineers working with every client in the region. Number 2, a key goal for us is our team is improving the operational resilience for our clients in the region, looking to prevent process loss incidents from occurring. And this is a topic that Zaid will explore for us just next. And number 3, we're looking to continually transform our services with new solutions in response to the changing industry expectations. And process safety has had a lot of focus this year, and those expectations are changing constantly. To help us understand what to focus on, we highlight these through our global benchmarking activities, as well as analysis on major industrial losses. And we look forward to Marine sharing some of these cases after Zaid. So next, it gives me great pleasure to hand you over to Zaid Lafter to present some of our core activities as well as recent accomplishments.
Thank you, Nick, and thank you everyone for letting us present. So this year, process safety has become even more important in our industry. So it's critical we provide a truly great experience for our customers. Our core service is to provide operational and construction risk engineering consultancy, both for the clients in helping to reduce their risk profile, and for insurers where the risk is ultimately transferred. We do this first by quantifying the risks. Through site visits, we ascertain the implementation of hardware, the management systems, and emergency response tactics. And then we support this by our modeling capabilities. You'll see an example output from our modeling on the next slide. Throughout, we work in collaboration with our clients, whether it's delivering loss prevention seminars, workshops, process safety culture assessments, and various deep dive activities, to name a few. Our position papers, in particular, have been of significant value to our clients in explaining the latest in industry standards, and where we make risk improvement recommendations. These then help bridge the gap by detailing expected actions in a best-in-class work process or hardware features. All of our position papers and publications produced by Marsh's Global Risk Engineering team are made freely available on the Marsh website. The 100 largest losses, and you'll see an icon just on the right, is particularly popular, and it's made mandatory reading at a number of our client sites. And again, you'll see an example graphic from the 100 largest losses on the next slide. So ultimately, we're fortunate to be in a position where we work with a large number of clients around the world. That allows us to compile and compare sites' performance through our analytics and benchmarking, which puts us in a unique position to influence industry standards across the board. And of course, no meeting this year has gone ahead without mentioning COVID-19. So in terms of COVID-19 response, we're particularly proud of our business continuity plans. So we led our industry sector in implementing business continuity plans to ensure we continue to service our client needs. This was initially by setting an industry standard on virtual surveys, and now with adopting augmented reality headsets that allows us to remotely tour the sites. And with that said, I'll hand you over to my colleague Marilyn.
Thank you, Zaid. Thanks, Nick. Our benchmarking allows us to do a comparison with a peer group within a global population or a more targeted peer group if required. Our dynamic benchmarking database has data from over 1,000 surveys going all the way back to 2004, looking at more than 250 clients and over 750 assets. A client's loss prevention performance is presented in classic quartile type reporting, which makes it clear when change is possible or even required. As part of the analysis, we would suggest improvement opportunities, and if appropriate, we can also analyze the impact of implementing those improvement opportunities on future performance. So this is a valuable data, obviously, for a risk manager, but also a useful tool during the insurance placement process as a way and means of doing risk selection and risk differentiation. I would say our ability to give a third-party view on what good looks like has really been instrumental in driving client improvement. A key goal for our team is to see improved risk quality of energy operators in the region, especially when compared to their global peers. A good example of this is where we supported a regionally based global petrochemical operator achieve top quartile performance through identification and closure of over 2,000 risk improvement recommendations over the client relationship life. We know that the onshore oil, gas and petrochemical industry has seen a large number of losses attributed to asset integrity failure and also inadequate control of work and operator discipline. And in response to that, we developed a deep dive service, which is essentially a suite of in-depth surveys carried out by specifically or specially qualified and certified engineers to give a better understanding of the risk, but also value add recommendations and insight. We maintain process models for over 150 million tons of global integrated oil, gas and petrochemical production. Our industry leading process optimization and supply chain interdependency experts drive gross margin improvements also to assist with post-loss event planning. We support corporate stewardship of risk engineering activities through hosting corporate insurance management stewardship forums, which we use to justify improvements through the use of, for example, KPIs, analytics, benchmarking, and also process safety culture assessments. We see this as a powerful tool from which to support risk managers, to get buy-in, but also to influence key stakeholders and sponsors to ultimately drive long-term benefits for loss prevention and also corporate governance. We believe that with the insurance programs or placements that we support, that we are providing balance sheet protection ultimately allowing companies to invest, which is to the benefit of the wider society in terms of prosperity, job security, and also economic growth. And with that, we would like you again to thank you again for the opportunity to present. It is wonderful to get the recognition of an institution like the IChemE, and I must say, listening to the level of diversity in what we've heard today, it's really been remarkable and inspiring. Thank you again for the opportunity, and we are happy to take questions.
Okay, thank you very much. So once again, if you have a question, please use the questions box on the GoToWebinar portal. Well, I'll give you a moment on that. Don't forget that both of our award winners from today's webinar also automatically qualify as finalists for our top prize, the Outstanding Achievement in Chemical and Process Engineering Award. The winner of that prize will be announced later this month. Okay, I don't think we have any questions, so thank you to all of you. We will move on. It's time for our fifth finalist from Arena Tech. Please welcome Emily Trowitz-Jones.
Hello, and thank you very much. My name is Emily Trowitz-Jones, and I'd like to talk to you today about a service which Arena has developed regarding the REACH regulation and how to effectively meet the compliance obligations. So a little bit on Arena itself to start with. So Arena is a global company in over 65 countries, and offers a very wide variety of services ranging from power to marine and many other areas. I'm part of the product regulatory compliance team in the UK, and we work with legislative bodies and competent authorities such as the European Commission, as well as national authorities, as well as manufacturers and importers of engineering products. We offer a number of services about identifying, understanding, and how to effectively meet technical and environmental legislation. So today I'd like to speak to you about a particular service regarding the REACH regulation. The REACH regulation is a piece of EU chemical regulation and effectively puts obligations on pretty much everyone in the EU who uses chemicals, as well as providing articles to other companies. It is the most complex bit of environmental legislation relating to chemicals there has ever been, and is over 500 pages of legislation as well as associated guidance. So for companies who are operating and affecting have obligations under this regulation, it can be quite complicated about what you need to do and how to manage these in an effective way. The types of obligations obviously depend on the type of activities undertaken by each company and can be quite varied. The one which I'd like to dive in a little bit deeper is that when a company provides a product to another company, if it contains something called a substance of very high concern, they are obliged to provide information about that substance, as well as provide safe use for that article. Now, a substance of very high concern, as you can tell by its name, is something that isn't particularly nice. It often has an engineering reason for being contained within the product and is classified of the fact as an SVHC because it's a carcinogen, mutagen, or radioactive substance. So although there is often very good reasons for these being contained within products, the use of them is being kind of driven out of articles, and so that people are understanding what's contained within their products, the information needs to be communicated to the next person in the supply chain. So the way that many companies can approach this compliance obligation is kind of a tiered approach, really. So on the far left-hand side is kind of a passive approach. So in the supply chain, often this is many different layers down. It can be that there is no kind of proactive information gathering, but it relies on kind of supplier due diligence to communicate this information and pass it along. Generally, this is a very kind of sporadic approach and doesn't mean that there's a lot of confidence or ability to demonstrate this compliance has actually happened and the relevant data has been obtained. A kind of a slightly more robust approach and middle box is that a lot of effort can be expended about trying to gather this information. So there are currently over 200 substances of very high concerns or SVHCs, which currently have to be communicated if they're within products. This list often changes as well on a kind of a biannual basis. So it's kind of trying to hit a moving target and making sure that all the relevant information is obtained. Generally, the response rate that we've seen across varying different industries is only around about a 30% rate, which doesn't mean that all the relevant information is communicated. And it's particularly difficult for small to medium-sized companies or non-EU suppliers who are less familiar with EU regulatory requirements but are still impacted by them. Another type of approach is that you test everything. So these substances have specific tests which you can then, for every single product, test all of the components and materials inside of it. But this is very costly and time consuming, and often only some parts are tested due to those limiting parameters. Because of these two kind of disparate approaches, which represent kind of the different ends of the spectrum of compliance, RINA has developed a kind of a focus to try and bridge the passive to information requests. And the way that we've done this is that effectively we have developed a tool and a way of analysing what substances are most likely to be contained within certain product types. This results in a much more focused approach, and therefore the costs of compliance are reduced as you don't have testing costs, but also it reduces the number of hours that you have to do to reach out to suppliers or try and demonstrate to competent authorities when they ask for compliance information about how you've met this. It also increases the likelihood of all the SVHCs being identified. So it increases from 30% up to kind of 70 to 90% typically. And this means that often companies are then able to release money that they would have spent obtaining kind of supplier information to invest that money in research and development activities about finding safer alternatives to these substances of very high concern while still meeting their technical challenges of their products. So the way that RINA has developed this assessment tool is kind of a review process to try and identify the high risk parts. Once these high risk parts are identified, it then allows kind of the tailoring of safe use instructions so that the customers are able to use the products carefully and appropriately. But the way that this is done is through kind of 4 streams of information. So the first is that the trends and how chemicals are used for certain products and materials change over time as market influences often develop over time and new chemicals are substituted for safer ones, and that different geographical areas tend to use different chemicals more predominantly. So RINA monitors this and is able to give an idea about how likely a certain substance is able to be used. There is also the underlying chemical properties and how they correlate to the technical performance of the part. So, for example, certain plasticizers in rubbers have given certain properties about the rigidity of certain plastics, and that is able to immediately correlate about which ones are able to be used or which ones may not actually be retained in the final product. There's also a number of publicly available information sources. So national enforcement authorities often undertake surveillance activities and test products in the market to make sure that people are safe. And these are provide a kind of feedback loop. RENA also does testing for some companies, and that's that kind of middle approach in the previous slide. And that also has a kind of unique source of information about what SVHCs are most likely to be used at any one time. So from that, you can effectively go from a list of over 200 substances to a list of, depending obviously on the product type, to 10 or 20 or slightly more. And this means that the higher risk parts and understanding what chemicals are used that may influence either its use or even recyclability are able to be focused on. The benefits of this is that obviously there's the cost element of the activities that are used to demonstrate compliance are much reduced. So tailored engagement pieces can be undertaken, and that the company undertaking this type of activity can have a greater confidence in the level of information achieved, because the percentage kind of responses go up quite substantially. Also that information is communicated in a lot more expedited manner. So this means that the provision of safety and safety information is happening in a lot more slick and effective way. The biggest benefit that we see really is that substances of very high concern, and the whole basis of the REACH regulation is to try and drive products which are using substances which are more benign, either through impacts to human health or the environment. And that many companies that we engage with use this cost and time savings allow them to identify the products which they need to redesign and move to a safe alternatives, undertake a lot more of these activities. The benefit is that obviously when these products come to the end of life and need to be recycled or put into landfill, it means that these substances aren't entering our environment, either the processing stage as safe alternatives have been found, or that the products themselves don't contain these. And that really is quite a wide and far-reaching benefit, and one that we really like to support our customers with. With that, I'd like to thank you very much for your consideration and attention, and would like to open it up for any questions if anyone has any.
Okay, thank you, Emily. So we will pause, and if you have a question, please type it into the questions box on the GoToWebinar portal. Okay, we don't appear to have any questions, Emily, so we're going to move on. Thank you very much. We have one more finalist, and this is a pre-recorded video from Worley Group. Okay then, so that was a pre-recorded presentation, but Avinash is with us. So if anybody does have a question, he's happy to answer them. So we'll just pause for a moment and please type your question in the usual way if you have one. Okay, if not, it's time for the moment that everybody's been waiting for. So firstly, a big thank you to all of our finalists for sharing their work and being with us today. Some very worthy entries, I'm sure you'll all agree, but we can only have one winner. We start with our highly commended entries, and they are from Marsh JLT Specialty and ABB Energy Industries. So well done to everybody involved in those projects. But now it's time to announce the winner. So ladies and gentlemen, the winner of the IChemE 2020 Best Consultancy Award sponsored by the Chemical Engineer is Engineurs. So Alex, Richard, hopefully you're both still with us, and if you can come back on, come and tell us how it feels to be IChemE Award winner.
Wow, amazing. Thank you very much, IChemE.
Is there anybody else you want to thank while we're on the call?
Alex, you're on mute, I think.
Sorry, still a little bit shell-shocked. Amazing, incredible. Yes, our customers have been incredible. Our partners have been very patient with us over the past 5 years. Our employees have been, they have the same passion and drive as we do, and really make the company what it is. And so we'd really like to thank the IChemE as well for the recognition, and I think chuffed is an understatement.
Well, thank you very much.
I echo that.
And well, congratulations, and well done
So,
to all of our finalists, and thank you everybody for being with us today. There's still plenty more IChemE Award webinars to come, so they are all free to attend and open to all. So please head over to our website if you'd like to be part of the other sessions coming up in the next few weeks. But for now, it leaves me to say congratulations to Engineers and the University of Hong Kong, and goodbye.
Thank you.
thank you very much.